Okay, I'm back, and now we want to explore harmonic motion with a spring. But before we do this, I need for you to do a little bit of reading. So I want you to go to your PowerPoint that goes with harmonic motion. And so that is PowerPoint number 14, Vibrations and Waves. So go to that PowerPoint, and then I need for you to go down to slide number, I want you to look at slide number 12, which should say 3 force of a spring, Hooke's law. Okay, and it says that the force on a spring is going to be equal to the spring constant of the spring multiplied by how far the spring stretches whenever you put a mass on it. Okay, so we're going to be making use of that formula. And then I want you to go down to slide number 13 on PowerPoint number 14 from your lecture notes. And you see the sample question where you calculate the spring constant of a spring. So it's very important that you read that PowerPoint before you proceed with the lab. It will make the lab so much easier if you'll read that first. So it says that a spring is originally 10 centimeters long, a 30-gram mass is hung from it, the spring stretches to 25 centimeters long. What is the spring constant of the spring? So we know that the initial length is 10 centimeters, which we need to convert to meters. The final length is 25 centimeters, which we need to convert to meters. The change in length of the spring, we're going to subtract those two numbers. And we also know what the mass is that's being hung from the spring. And notice we have to convert that to kilograms by dividing by 1,000. Okay, now the weight of the mass, so the force of gravity pulling down on the mass, must be equal to the force on the spring pulling up on the mass. So the weight of the mass, the force of gravity acting on the mass, is equal to mg, where g is the acceleration due to gravity. So if you combine equations 14.5 and 14.4, then you get that equation below it that says the mass that's pulling down on the spring multiplied by gravity is equal to the spring constant of the spring, and then how far does it stretch? So we plug in all of our numbers and then we solve for the spring constant. Okay, now it's very important that you understand that, because now we're going to go to the lab. So it says to measure the length of an unstretched spring. So I went out to Lowe's and I got a little spring that you use to hold open your screen door with. Okay, and then I'm going to measure the length of this unstretched spring. Now what I want to do is I want to measure the distance from the top of the spring down here to the bottom. Okay, now I know that this is really difficult for you to see, but I'm going to put the spring on the 20 centimeter mark. And I'm going to try to get my big fat fingers out of the way. Okay, so that you should be able to measure the length of that spring. Okay, so one end of the spring is at 20 centimeters, and then I want you to measure where the end of the spring is at. So don't include that circle thing on the end of it. So you see this the spring has a circle, and that's where you attach it. So don't include that circle. So you are only measuring from one end of the spring to the other end of the spring. Okay, now you're going to record that as the measured original length of the spring in centimeters, and then convert it to meters. So the number that was on here, these numbers, those are in centimeters. Okay, so you got that? All right, now it says to measure the length of the spring after a mass is added. Okay, so here is going to be my mass. Okay, now I want you to count how many discs there are, including the bottom one. So you got this one down here, and then this one, and then this one. So count how many discs there are. Okay, each disc is going to be 50 grams. So take the number of discs, multiply by 50, and then that is the mass of the weight that I'm going to suspend from the spring. Okay, you're going to put that in that first yellow box, and then you got to convert it to kilograms. So put that in the second box. All right, now calculated weight of the mass using equation 15.5. So we're going to find what is the force of gravity acting on this mass. That's its weight. So it's going to be mg. So you know what g is. Multiply that by the mass in kilograms and put that in the next box. Okay, you know what the measured original length of the spring was. So we've already given you that. Now what I'm going to do is I'm going to suspend it. So what I did was I put, so let me make sure that you can see this, and I put the spring onto the end of a pencil, and then I duct taped the pencil down to the table. So it's suspending there. Okay, now I'm going to hang the weight from it, and it's going to stretch. So when I put the weight on the end of that spring, now notice that the spring is stretched. Okay, and then I'm going to measure the length of that spring, and so it's going from 0, and then it's going all the way up to let's say 11.8. So the stretched length of the spring is going to be 11.8 centimeters. Okay, so now you're going to put that in the measured length of the spring after the mass is added. And remember, you got to divide that by 100 in order to convert it to meters. Okay, now you can find the calculated change in the length of the spring. So again, go back to the PowerPoint if you want to see a worked out example of everything that I'm doing here. Okay, then calculate the spring constant. So you've got enough data now in order to be able to find the spring constant C. So just follow the instructions on the PowerPoint that we just went over, and that will tell you exactly how to calculate the spring constant of your spring. So go ahead and do that right now. I'm going to stop the video here, and when we come back, we're now going to use that spring constant in order to calculate the frequency of the spring.